So now what is the Kirchhoffs law that we will study? So there are two Kirchhoffs law. One is the Kirchhoffs current law and another is the Kirchhoffs voltage law. So let's say first of all what is mean by that electric network. Yeah, so the electric network obviously which consists of your different components. One is nothing but this resistance, yeah, so which are just joined together to form this your network. Yeah, again what is junction? So in case of junction, where I will say that more than 2 or 3 resistors are connected together, so this is nothing but, let's say for example, it is a junction. Yeah, so let's say this point A is forming the junction. Then further we will say that what is that loop, or also it is called as a mesh. So it is forming that closed path. Yeah, so this ABCD is nothing but the forming the closed path, so that is a loop or mesh. Again this AB is called as a branch. ABCD, DA, all those are nothing but your branch of that network. So now what is the first Kirchhoffs law or the junction rule? So the total incoming current is equals to the total outgoing current. So let's say for example this I1 and I2, they are moving towards the junction. Yeah, so sum of the incoming current is same as that of your sum of the outgoing current. Yeah, so this is how we can write it down. So I1 plus I2 is equals to I3 plus I4. Yeah, so this is how we can just write it down, that your Kirchhoffs junction rule or the Kirchhoffs current law. Or according to sign convention, if the current is moving towards the junction, consider it as a positive. If it is leaving the junction, then consider it as a negative. So in this way, that I1 plus I2 minus I3 minus I4, it has to be equals to 0. So this is how we can write it down. So that is a delta I also equals to 0. Yeah, fine. So this is how we can write it down for this Kirchhoffs current law. So incoming current is same as that of your outgoing. So now again the Kirchhoffs second law, so which we are going to see that the algebraic sum of the current around the closed path. Yeah, so algebraic sum of your potential, yeah, so algebraic sum of changes in potential must be 0. So let's say if I consider this is the path that is which consists of one closed loop, so the sum of algebraic sum of your voltage drop around the closed path is always equals to 0. So for this case, assume particular direction of current, then according to direction of current give the polarity. So this is plus minus. If you are just tracing from plus to minus, then according to sign convention write it down as a minus. If you are moving from minus to plus, write it down as a plus. So this one you can write it down, that is a minus IR1, then that is minus IR2 plus V is equals to 0. So again you are going from minus to plus finally. So that's why we have just considered that as a plus. So this V you can write it down finally, that is a IR1 plus IR2, or you can further, that is a V upon R1 plus R2 is equals to I. So this is the value of current through this circuit. So this is how we can write it down the sign convention. If you are moving from minus to plus, write it down as a plus, plus to minus, minus IR, again minus to plus, that is plus IR, and again this is minus. So this is how you have to write it down. So now for example, for this case I will just write it down. There are two loops. Let's say this is the first, this is the second. So if I write it down for the first loop, so starting from this one, so that is how we can write it down. So further this is according to the sign convention, write down the direction. So this is plus minus, again this is plus minus. Now trace this loop. Yeah, trace this loop in any direction. Yeah, so let's say that for example I just trace it from your AB part. Yeah, so this is minus to plus. So A to B, obviously this is even, then this is minus I1 R1. Yeah, so consider, I will say that, so the first you can say that consider this loop which is A, B, C, F, A. Yeah, that is even minus I1 R1. Then you can write it down plus I2 R2 minus E2 is equals to 0. Yeah, so this is your first equation. Now similarly write it down for another loop. consider the second loop. So where you can say that, so let's say it is, you can say F, C, D, E and F. Okay, so this is your E2, then this is, yeah, again we can say that further. So that is a minus I2 R2. You can go from in any direction. Yeah, so again that is nothing but your minus. Okay, so this is minus I2 R2 and then this is minus I1 plus I2 into R3, which is equals to 0. So you have got now these two equations and there are two variables I1 and I2. Just solve those two equations and you will get the resultant value of your I1 and I2.